everyone! Today we are here to talk about the phases of matter. But for now, let me ask you some questions. How water changes phase? And how particle of water behaves and why? Well, you will find out the answer to those questions if you listen our discussion. Let's get started!
Water can exist in four phases: solid, liquid, gas, and plasma, plus a few other extreme phases like critical fluids and generators. Sometimes, the solid will go directly from solid to gas. This is called subliming. An example of sublimation is brightness. The solid form of carbon dioxide, CO, which turns into gaseous carbon dioxide at standard temperature and pressure. There is no liquid phase of CO at standard temperature and pressure.
With one negatively and one positively charged end. Depending on the temperature, these depots align themselves into aggregates according to their charge. For example, in the formation of ice crystal, the depot character of water is a critical factor for climbing, because the water depots tend to hold together like small magnets. Water reacts sluggishly to warming or cooling. In fact, water has the highest heat capacity of all liquid and solid substance, with the exception of ammonia. This means that water can absorb large amount of heat before it boils. Both freezing and boiling point of water, so much a part of our daily lives, are really rather unusual. If the water molecule were symmetrical, then water would melt at minus 110 degrees Celsius and boil at minus 80 degrees. The inertia of climbing is a result of high heat capacity of water in the first place.
Water influences climbing not only in its liquid and solid states. H2O is the form of water vapor in the atmosphere as a decisive impact of heat budget of the Earth. Water vapor alone is responsible for about 2/3 of the natural greenhouse effect. In addition, it amplifies the impact of other substances on climate. For example, if the temperature rises as a result of higher carbon dioxide levels, then the water vapor content also increases because the warmer atmosphere can sustainably hold more water vapor. Because of its dipole molecule, water absorbs infrared radiation very efficiently.
As air dissolves, it approximately doubles the warming originally caused by carbon dioxide. Another important property of water is its ability to dissolve salts, which significantly change its density. The average salinity of the ocean is 34.7 parts per thousand, as this salinity water has the greatest density of minus 3.8 degrees Celsius, which is below the freezing point of seawater with average salinity. This is in fact minus 1.9 degrees Celsius, so surface cooling can cause convection until ice is formed. This density rate is the engine for convection, one of the most important elements of the climate system. Called salty water is heavy and seems to be great depth. It is replaced by water flowing into the surface.
In our introduction, we will ask some questions. First, how does the water change its phase? Our example is water and ice, water and steam. How can you have water and ice at the same temperature? How can you have water and steam at the same temperature? The key is that temperature does not measure the entire internal energy of substance, only the translational kinetic energy part during a phase change. The energy goes into the potential energy part, either talking from adding to the energy associated with the molecular attractions.
The constancy of temperature when water is going through its phase changes at 0 degrees Celsius and 100 degrees Celsius provides some insight into the nature of internal energy of water, ice, and steam, and into the nature of temperature. The large size of the phase change energy indicates that there is a large amount of potential energy associated with intermolecular forces between the water molecules. During melting and and therefore not changing the average translational kinetic energy as reflected by the temperature.